Hi again. Okay, so now we're going to move on to lesson 90. Lesson 90 is systems of three equations. Basically, it's going to be solving equations that have three different variables. So if you have three different variables, they're going to be x, y, and z. You can only solve if you have three separate equations. And I'll tell you ahead of time that we are going to write our answers in the form of a triple, which means the value of x will be first, the value of y will be second, and the value of z will be third. So this is the form that the answer will be in. I'm kind of getting ahead of myself though. So let me show you what I'm talking about. So if we have three equations, the first one will be x plus 2y plus z equals 4. And then our second one will be 2x minus y minus z equals 0. And our third one will be 2x minus 2y plus z equals 1. Okay. You could use substitution by rearranging these equations and solving for a certain variable and then plugging it back in. It gets a little complicated when you have three variables because sometimes you end up going in a circle. So an easier way to do this is to pick one of the variables, either x, y, or z, and use elimination to get rid of the variable altogether. And you're going to do that twice, and that way you'll end up with two equations with two variables, which is much easier to work with. Here's what I mean. In this one, we're going to call this equation A, this equation B, and this equation C, just to sort of keep track of things. If we add equations A and B together, the z will eliminate. And that will make it much handier for us. So we're going to do that. We're going to take equation A and equation B, and we're simply going to add the entire equations together and eliminate them. So x plus 2x is 3x. 2y minus y is 1y, so it's just plus y. And a plus z plus a negative z is just 0. And then that would equal 4. So do you see how by combining these two equations, we get an equation 3x plus y equals 4 that only has an x and a y. So now we're going to do it again. Only see right here we added a and b. Now we're going to add b and c. And because when we do that, we're going to get rid of the z again. So we'll take equation b again, 2x minus y minus z equals 0. And we'll take equation c, 2x minus 2y plus z equals 1. Now we're going to add those two together. 2x plus 2x equals 4x. Negative y plus a negative 2y gives us a negative 3y. The z's go away because a negative z and a positive z equals 0. And then this equals 1. Now we have something we can work with. We have 3x plus y equals 4 and 4x minus 3y equals 1. In your book, they do elimination again with these two equations, but you can at this point simply do substitution, which I like that a little bit better. So I'm going to rearrange this equation and say that y equals 4 minus 3x by subtracting 3x from both sides. Now I can take this, since y equals this, I can substitute that in for the y on this side. You guys have done this before, so this part should look pretty easy. Now you have 4x minus 3 times 4 minus 3x. The trickiest part will be keeping track of your signs. So let's finish this up. We have 4x, a negative 3 times 4 is negative 12. And negative 3 times negative 3x is a positive 9x equals 1. So combining like terms, 13x equals 13, because we're going to add 12 to both sides. Dividing each side by 13 means, oops, you can't even see what I wrote right there. When moving from here, we divide each side by 13, we get x equals 1. So once you find out that x equals 1, we can put it in, let's say, this equation right here. 3 times 1 plus y equals 4. So y equals 4 minus 3, so y also equals 1. So now we have that x equals 1 and y equals 1. Remember I said we were going to write this in the form of a triple. So far we have a 1 for x and a 1 for y. Now we need to solve for z. We can go up to this equation and put 1 in for x, which would give us a 1, a 1 in for y, which would give us plus 2, plus z equals 4, 3 plus z equals 4, subtract 3 from each side, z equals 1. So in this problem, x, y, and z all equal 1. So it would be written like this in the triple. So basically the steps are to take your first two, find a variable, and you're going to try to eliminate it. First by adding two equations together, then by adding two different equations together. And that will give you two equations with only two variables. We're going to try another one just to make sure that you got it. So in this one, we're going to have our first equation, 2x minus y plus 3z equals 9. X plus 2y plus z equals 8. And x minus 2y plus z equals 0. In this case, it would be easier, and you really can do whichever variable that you would like to try to eliminate first. I'm going to go with the y, and we're going to say that this is equation A, this is equation B, and this is equation C. We're going to start off with a simple one because here, this 2y and this 2y, you can see will eliminate each other. So if we take equation B and equation C, and we're going to add those two together. X plus x equals 2x, 2y minus 2y equals 0, z plus z equals 2z. So we have 2x plus 2z, and 8 plus 8 equals 16. So we have 2x plus 2z equals, I'm sorry, I did a mistake here, because this should be 0. This equation C should be set to equal to 0, so that means our equation added together, 8 plus 0 would be 8. Sorry about that. Okay, we did B and C, and now we're going to do A and B, and we're going to try to eliminate y. When we add A and B, we can see that the y's are not the same. So if we added those two together, they wouldn't eliminate. So we have to multiply this first equation by 2 so that it would be negative 2y plus 2y. Then they would eliminate. So we're going to multiply this first equation by 2. So multiply this entire side by 2, and then we multiply this side by 2. 9 times 2 is 18. We're going to do the distributive property, which gives us 4x minus 2y plus 3z equals 18. Now we're going to add this equation, which is b, to this equation that we just multiplied by 2. We're going to take and add x plus 2y plus z equals 8. When we add those two equations together, we get 4x plus x is 5x. The negative 2y and the positive 2y cancel out, and they make us just 0. Then we have 3z plus z would be 4z, and 18 plus 8, which would be 26. You know what? I did another mistake. I was wondering why that wasn't 7z. Okay, so right here we did 2 times 2x, which would be 4x. 2 times negative y is negative 2y, but I forgot to do the distributive property here. 2 times 3z, this should be a 6z. Did any of you guys catch me earlier when I did that? If you did, let me know and I'll give you an extra credit point on your quiz. Okay, so then when we multiply 4x plus x, we get 5x. The negative 2y plus 2y, this cancels out, and now we have 6z plus z equals 7z. So I'm going to rewrite that so it doesn't look so messy. 5x plus 7z equals 26. That looks right. I knew something was wrong there. Okay, so now I have these two equations. I have 5x plus 7z equals 26, and I have 2x plus 2z equals 8. So from here, I can simply use substitution. I'm going to solve this one for z. So I'm going to subtract 2x from both sides. I get 2z equals 8 minus 2x. I'm going to divide each side by 2. Dividing this by 2 and dividing this by 2 gives me z equals 4 minus x. Now that I have, I can just simply put 4 minus x in for z over here. So I have 5x plus 7 times 4 minus x equals 26. Using the distributive property gives me 28 minus 7x equals 26. And this side is 28 plus a negative 2x or a minus 2x equals 26. I add 2x to each side and I subtract 26 from both sides. So 28 minus 26 is 2. I add 2x to both sides. That leaves 0 on this side and 2x on this side. Divide each side by 2, so x equals 1. Again, we have an x equals 1. So we're going to start our triple answer right here. Well, now when we find out that x equals 1, we can go ahead and solve for our z. We can use this equation right here. If we put 1 in for x here, we have 2 times 1 is 2, plus 2z equals 8. So 2z equals 6, and z equals 3. So that's, whoops, I should have done y first, but anyway, we'll put our 3 in here for z, and we left room for what our y will be. So now we have to find an equation to put in to figure out what y is. We'll go up here, and we'll take a look at this one. 2x would be 2 times 1, which would be 2. And we're going to subtract y. We don't know yet what y is. And then we're going to add, we're going to put in, we found out that z was 3. So 3 times 3 is 9. And that's equal to 9. So we have 2 minus y plus 9 equals 9. If you add y to each side and subtract 9 from each side, then that gives us that y equals 2. So that's the remaining part of our triple. So the answer to that system of 3 equations would be 1, 2, and 3. So the basic steps. You have your 3 equations. It was A, B, and C. You figure out which variable would be easiest to eliminate. You add 2 equations together to eliminate that variable. In this case, we chose y. So then you need to pick 2 different equations. Here we did, we started off doing B and C right here. And then the second time we tried to eliminate the equations, we used A and B. But when we did A and B, we had to change this y to a 2y so that it would cancel out. So we had to multiply this first equation by 2, which is what we did here. When you add those 2 sets of equations, you end up with 2 equations that have only 2 variables. Here are the ones we ended up with. And then from there, you know how to solve that. You simply use substitution. So I think you guys are going to be just fine with lesson 90.